All right, page 3 of the study guide. So we have graph the function f of x, and here they're giving me the function. A few things that I need for graphing the function, and it's pretty nice that they're giving it to me here. I need to find the vertex. I need to find the line of symmetry, which is going to be an its value. And I need to find the X-intercepts, which are pretty much the zeros. X-intercepts are the zeros. Remember the zeros. And to find the zeros and all of these, pretty much I need to first of all find my factors. So two numbers on one multiply give me -8, and when added give me +2. 4 times 2. 4 times 2. Which one has to be positive? Which one has to be negative? 4 has to be positive. 2 has to be negative. +4 times -2, -8. +4 and -2, +2. That means my factors are going to be at, we said -2. So at -2 and at +4. There are my factors. That means my X-intercepts will be the opposite of what I have in here. My X-intercepts will be at +2 and at -4. That means that in my graph, when graphing it, I'm going to have factors at +2 and at -4. My graph has to go through these points. All right, my graph will go through these points. It's asking me for the line of symmetry. Let's look for the line that's in between these 2 points. So if I go 2 here and then 2 here and then 1 and then 1, there you go. That's a point in between. That means that my line of symmetry is here at x equals -1. So at x equals -1, I get my line of symmetry. Now to find the vertex, I need to put this x value of the line of symmetry into the equation. And again, it doesn't have to be this equation. I can change into the factor form of the equation, because these two are essentially the same thing. This is just in another form. I really like it putting it in this one because it's simpler. So I'm going to take the -1 and I'm going to replace it for every x. So I'm going to have -1 and -2 for the first parentheses times -1 plus 4. Wait, -1, sorry, plus 4. That simplifies to -2 and -1. That makes -3. And -1 and +4. 4 is bigger, so it'll be +3. -3 times +3 is -9. -9. This 9, if we look, trace it back, it's my y value. -9 is my y value. And the line of symmetry, that is my x value. All right, that means I know that my line of symmetry was going to be a -1. My line of my vertex was going to be on the line of symmetry, -1, and it's going to go 9 units down. 2, 4, 6, 8, 9. There you go, right in the middle, as I said, at -1. And it goes 9 units down. So from here, my graph will look something like this. It doesn't really have to be perfect again. Just make sure that it looks like a U, and you should be fine. And there you go. That's my parabola. You say graphing calculator. We're not going to be using graphing calculators. So you can skip 14. 14, that goes on to there. And 15, compare the graph of... So here we're comparing two graphs. graph as a function and describe the change. All right, so number 15, we can do this pretty simple. And here's how it works. For 15, I'm going to be letting you use the graphing calculator that comes in Desmos in the computer. And it's pretty much understanding what is it that the 3 does and what is it that the 1 does. We've seen this before when linear equations. We know that -3, it's going to shift the equation 3 units down, and the positive 1 is going to shift the equation 1 unit up. All right, they both start at the origin here. One of them is going to shift 3 units down, and another one is going to shift 1 unit up. We know that. Now the 4, it's going to make something to the graph. The 4, pretty much if you look at a line, the 4 kind of represents the slope. If you look at a line with slope 4/1, that means that the slope from a point, it'll make 1 unit over and 4 units up. That means that the line, the graph, is going to be narrow. It's going to be skinny. It's going to be compressed horizontally. It's going to be skinny. You take a look at 1/2, a number where the number in the denominator is bigger, we get a longer run and a shorter rise. That means the graph will be stretched. Right? Just by looking at linear graphs, we can interpret how this will look. So this one, the one that went 3 units down, it's going to be skinny. It's going to look skinny. All right, compared to the one that went 1 unit up. This one's going to be a little bit more wider because, well, you saw the slope. It makes the graph wider. So the slope will be wider. All right. So this is pretty much what it's trying to kind of get you to understand. And it's going from this one to this one. We know from this one, which was skinnier, it became wider. So what happened? It became wider. Again, from this one to this one, it became wider. From the skinny to this one, and it went pretty much shifted upwards. Shifted upwards. All right. And in Desmos, you can see pretty much that. If you take a look at how the graphs look in Desmos, this is how they look. Notice it shifted 1 unit up. That's 2, so it went 1 unit up, and the red one went 3 units down. So that's pretty much how it works here. Just identifying what the 3 does and what the 4 does. And again, if you have trouble with this, you can and just draw the line. This is the slope, that's the slope, that's the slope. And just visualize it. It's 1 over, 4 up. This is going to be a skinny graph. This one is 2 over, 1 up. This is going to be a wider graph. And that's it. That's 15.